Okay, here's our activities series worksheet, and these are all single replacement reactions. You'll need a couple of things. You're going to need this activity series of metals chart. If you don't have one, I have one in Canvas that you can print out or just pull up on your computer. All right, so you need this, and of course your handy dandy ion chart. Okay, so let's look at number 1. These are all single replacement, and if you look down the sheet here, there's a single element that's going to replace one of the other elements in this compound over here. Okay, so we got to figure out if this guy is going to replace one of these. Okay, how do we know? All right, well, here's potassium. Okay, potassium is a metal. Metals cannot switch places with nonmetals. They can only switch places with other metals. So the question is, will potassium and zinc switch places? Okay, well, right here. These are metals on the left-hand side, nonmetals on the right. So we're going to find the two metals here that we're going to decide are going to switch places. So we have potassium and zinc. So I find potassium, here's potassium right here towards the top of the scale, and I'm going to keep going a little bit further down, and there's zinc. Okay, I also call this my hotness scale because let's look here. Here's Miss Chlorine. Her current boyfriend is Mr. Zinc. Okay, and along comes Mr. Potassium. Now we're only going to trade up to someone much hotter. All right, and according to our hotness scale, who's hotter? Mr. Zinc or Mr. Potassium? Oh, Mr. Potassium, he's a lot hotter than Mr. Zinc, okay? And chlorine's superficial like that, so she's going to trade in her Mr. Zinc for Mr. Potassium. Okay, so what happens? Well, we're going to push zinc out of the way. Okay, zinc's going to be all alone now, all right? And who is going to hook up with Miss Chlorine? It's going to be Mr. Potassium. Okay, so we need the charges from potassium. Potassium's always a +1. It's actually here on this activity series if you don't want to keep looking back at your ion chart. Potassium's a +1, so the +1 potassium is going to be with who? It's going to be with Miss Chlorine, who's always a -1. Okay, so I've got the +1 potassium with a -1 chlorine, and they're going to be the new couple, okay? So those cancel out, so the new couple is KCl. Now I'm going to leave room to balance these out, okay? So if I'm going to balance these out, notice there's a 2 here. I don't bring that 2 over. Why is there a 2 there? Because zinc is a +2, always +2, and if a +2 zinc and a -1 chlorine combine, if you swap and drop, you get ZnCl2, which is what we have here. But new couple doesn't look like the old couple, but we still need to balance this out. So here I've got 2 chlorine on the left, so I'll need 2 chlorine on the right. And here, now I have 2 potassiums, I need 2 potassium on the left. And then I'm just going to put 1s in there. So now I have 2 potassium on both sides, 1 zinc on both sides, and 2 chlorine on both sides. So now it's balanced. But let's look at example number 2. So our single guy is lead. Lead is a metal, so he cannot switch places with oxygen, who we know is a nonmetal. So the question is, will lead and manganese, that's not magnesium, manganese, switch places? So I'm going to find lead and manganese. Here's manganese, and then I keep going further down. Here's lead. Lead's pretty far down on our hotness scale, right? So let's look. Current boyfriend is Mr. Manganese. Who's higher up in our activity series? Lead or manganese? Well, we just looked at that. Manganese is higher up than lead. So we will never trade down. We only want to trade up to a hotter element, okay? So looking at this, Miss Oxygen is going to stay with Mr. Manganese. She's not going to trade down. So we're going to write no reaction. Okay, so this is telling me if I add lead to this manganese oxide, which is manganese 4 oxide, and I try to get it to react, nothing's going to happen. Okay, it doesn't matter if I heat it up, stir, whatever, this reaction will never take place. Okay, now let's consider number 3. This one's a little bit different because the single person here is where? It's a nonmetal. Nonmetals can only switch with other nonmetals. And if you'll notice our activity series here, who's there? It's all our halogens. Okay, so there's chlorine. The only thing hotter than chlorine is a fluorine. Right? So there's chlorine. The only thing it wouldn't switch places with is fluorine. So we're going to do the same thing. Who's higher up, chlorine or iodine? Okay, so chlorine will not switch places with sodium. They're on 2 different teams. Sodium is on the metal side. Chlorine can only switch places with people on his team. Okay, so the question is, will chlorine and iodine switch places? Okay, not sodium. Because chlorine's higher up than iodine, the switch will take place. So basically, I'm just going to push iodine out of the way. Iodine's going to be alone. Is there anything special about iodine? Yes. Remember, all of these are special. Our Brinkelhoff, right? So it's I2, just like chlorine special, so it's Cl2. I'm going to leave a place to balance. Plus, sodium is now going to be with who? Sodium is going to be with chlorine. Let's go and get our charges. All right. Sodium, we know is a +1, right? Sodium's a +1. And chlorine, over here in our nonmetals, is a -1. A +1 and a -1 cancel each other out, so my formula is NaCl. And remember, your positive ion's always in the first position. Don't ever put your negative ion in the first position. Okay. So now we're ready to balance. Okay, I've got 2 chlorine on the left, so I need 2 chlorine on the right. Now I've got 2 sodium on the right, so I need 2 sodium on the left. That also gives me 2 iodine, and I have 2 iodine, so I'm just going to put 1s in there. All right, if you have any questions, let me know.